In today's video, we're going to look at the first part of section 6.2. There are a lot of definitions and tables, etc. that we have in 6.2, so I want to go through those first, and then we'll look through the second half in our next video. First thing I want to look at is what is a probability and what are the different types of probabilities that you will come across. In today's video, we're going to focus on the first type, but the other two do come up. So first, what is a probability? A probability is literally just a measurement of the likelihood of an event happening. Okay. So, for example, we can look at what's the probability of rolling an even number on a die. What's the probability that when we toss a coin 10 times that we will get heads 4 times? Okay, so you can look at all of these different types of probabilities. There are 3 main types. The type that we kind of stick with in this video is called a logical probability. And a logical probability is just obtained by using mathematical reasoning. So that brings us back to what we've been looking at with tossing a coin, with rolling a die, and looking at those probabilities of those things happening. Because there are a finite number of outcomes and each one has the same likelihood of happening, we can easily, by mathematical reasoning, figure out the probability of each event occurring. There can be more difficult problems that you can look at and look at their probabilities of events happening, etc. But in most of these, we're going to stick with things that are pretty easy to figure out what their probabilities are, as each event will have the same probability of happening. So a logical probability just means that you can obtain the probability by mathematical reasoning. So a particular probability could be the probability of a 6 landing face up on a die when you throw it. Okay. Whenever you write probabilities, we tend to do PR in front of it, open parenthesis, and then write what the event is that is happening, the event that you're trying to find the probability of happening. Okay, so it's normally PR. In some textbooks you'll find a P instead of PR, but in this textbook they use PR. The next type of probability that you can come across is called an empirical probability. Empirical probability just means that you are finding the probability by observation of an experiment. So an example of this could be the probability that a person selected at random on campus is taking a math class this semester. You survey a certain number of people on campus and you find that 100 out of the 300 that you surveyed are taking a math class this semester. That means that there's a probability of 1/3 that someone is taking a math class that semester. So it's all done by observation. This can also be called relative frequency in some textbooks. Okay, so you say that 100 out of the 300 are taking a math class. That's the relative frequency of someone taking a math class. Okay, so that's another term that you may hear instead of empirical probability. But that is what we tend to call it in this course. And the final type of probability that you need to be aware of is called a judgmental probability, also sometimes called an objective probability, and that is because it is just found by an educated guess. So you will guess at the fact that a certain number of people on campus are taking a math class this semester due to however many people were taking a math class last semester. So you're using previous data to inform your decision for this particular experiment. So I can say, okay, well, last semester I know that 150 out of 500 people were taking a math class. Okay, so I'm going to use that data in order to make an educated guess for how many people are taking a math class this semester. Okay, so judgmental probability is just obtained by an educated guess. This is also a thing that they use when you look at if you're betting on the fact that a certain football team's going to win the Super Bowl this particular year. Okay, you can look at previous data to see how the team has done in order to inform what the odds are going to be or the probability is going to be for the team to win the Super Bowl this year. Okay, so you're using previous data in order to inform your decision. Okay, next we're going to look at something called a probability distribution. A probability distribution for an experiment is just a table. And what it does is it lists the outcomes on the left-hand side and the probability of each of the outcomes on the right-hand side. So you're going to list your outcomes, we'll call them x1 through xn, on the left-hand side, and then the probability of each one, we'll call them p1, p2, through Pn on the right hand side. So the probability of x1 happening is P1, probability of x2 is P2, etc. In order for this to be the case, there are two fundamental things that we need to know about probabilities in order for this to actually be a probability distribution for a particular experiment. Okay. We've listed all of our possible outcomes here with all the probabilities of each outcome happening. Okay. So, for example, if I was rolling a die, my outcomes would be the numbers 1 through 6, and then I would have the probability of each of those values happening, which would be 1 over 6. We'll look at that in a second. But in order for this, for any experiment to be a probability distribution, we have two properties, and they are called the fundamental properties. Fundamental property 1. This states that each one of our numbers, P1, P2, through Pn, must be between 0 and 1. So each one must be a fraction or a decimal that lands between 0 and 1. The larger the number, the higher the probability of that particular outcome happening. Okay, so if you have a particular outcome that has a probability of 0 happening, that means it's never going to happen. There's no chance of it happening. If a particular outcome has a probability of 1, then it means that that is the only outcome that can happen. It's 100% the outcome that is going to happen. Okay, so each probability must be between 0 and 1. The second fundamental property states that each of the probabilities added together must equal 1. Okay. If we've listed all of our outcomes here with each of the probabilities, that tells us that at least one of those outcomes must happen. Okay, one of the outcomes on there has to happen. There may be outcomes on there that might not happen, but 99% of the time when you do a probability distribution table like this, you list the outcomes that at least have some chance of happening. Okay. If I take each of their probabilities, because I've listed all possible outcomes, one of them has to occur. So that tells me that I've got a 100% chance of one of these occurring, which tells me that if I added together all of the probabilities, there must be a 100% chance that one must happen. So if I add together all the probabilities, I should get 1. Like I said before, there are cases like tossing a coin, like rolling a die, where each of the outcomes has an equal probability of happening. Each outcome is equally likely to happen. So when we go ahead and do a probability distribution for these particular experiments, it's pretty easy in order to write out this table because all of the probabilities are going to be equal to one another. So let's do the probability distribution for tossing a coin. Okay, for tossing a coin, I've got my outcomes on the left, my probabilities on the right. So my outcomes are either heads or tails. The probability of heads happening is 1/2 and the probability of tails happening is 1/2. I have two different outcomes that are equally likely to happen. Whenever you have one of these particular experiments where all of the events are equally likely to happen, you take the number of events n, and then 1 divided by n is the probability of each event occurring. So if each event is equally likely to happen, and there are n events, or in this case outcomes, okay, each event only has one particular outcome in it, but if there are n events or n outcomes, then the probability of each occurring is 1 over n. Okay, so in this case we had two different outcomes, two different events, so we said that 1 divided by 2 was the probability of each one occurring. We can do the same for rolling a die. Okay, so I have my outcomes and I have my probabilities. Okay, my outcomes are the numbers 1 through 6. And then again, each one of these numbers has an equal probability that it will happen, okay? Each one is equally likely to happen. So there are 6 outcomes, so the probability of each one happening is 1 over 6. This is a really good example from the textbook. This time we are looking at empirical probabilities because they are what is observed. So here they have surveyed 141,000 college freshmen and asked what their intended major was. And so they've listed the outcomes, all of the intended majors on the left, and then the number of freshmen that wish to take that particular major on the right. And we've got to determine a probability distribution for this experiment. So in this case, we have the number of each particular major, and then we know that there were 141,000 freshmen that were surveyed. So in order to get our probability distribution, we list our outcomes on the left and our probabilities on the right. Okay, I'm not going to do all of these. You can go through and finish off the table, but we can see our first one is arts and humanities. So that's our first outcome. And then it tells us that 14,241 freshmen wish to take that out of the 141,000 freshmen that were surveyed. So in order to find the probability, it would be 14,241 divided by the 141,000 that were surveyed. Okay, and that will give you a probability, if you type that into a calculator, of 0.101. Okay, then you go and do the next one. So the next one was biological sciences. And it tells us that 21,009 of those 141,000 students intended to major in biological sciences, and if you type that into a calculator you get 0.149. So you keep doing this and it will tell you what that relative frequency of that particular major would be. Okay, so you just take the number that wish to take that particular major and then you divide it by the total number of freshmen that were surveyed, and that will give you the probability of each of those outcomes. So whenever you have one of these experiments where it does use empirical probability, this is what I want you to do. Take the number, divide it by the total number. Okay, you can go ahead and do this for every single one of your majors and divide it by 141,000. Once you've finished that table, the table is actually on page 248 of the textbook. You should find that you get this whole list of probabilities. Okay, so you get this whole list. So this would be your probability distribution. We need to make sure that this satisfies the two fundamental properties of probability. So the first one is that every single one of our probabilities lands between 0 and 1, which we can see here is the case. The second thing that we need to check is that they add to 1. You can go ahead and do that in a calculator. If you add together every single one of these probabilities, you end up with 1. You may have a slight rounding error in there, so please keep that in mind when you do this, but as long as it's close enough, it should take it. But there may be a slight rounding error, but they should still add to 1. The last thing that I want to go through is looking at the addition principle. Okay. The addition principle states that if an event E consists of several outcomes, so an event E, it's still going to be a finite number of outcomes, there's just going to be several of them. And remember that there is a finite number of them. Okay. Then the probability of the event E happening is just going to be the probability of A plus the probability of the outcome B, and you just keep going with however many outcomes there are in that event. This works as long as you have an event that has a finite number of outcomes. So for example, let's go back to rolling a die. Okay. We want to know what is the probability of rolling an even number. Okay. Well, the probability of rolling an even number is going to be the probability of rolling a 2, 4, or 6, which is just going to be the probability of rolling a 2 plus the probability of rolling a 4 plus the probability of rolling a 6. Okay, so we're using this addition principle. The probability of that event E happening, the probability of rolling an even number, is just going to be the probability of rolling each of the even numbers added together, which we know from our previous probability distribution that each one is 1 over 6. And if you add those together, you should get 3 over 6, which is 1/2. They've done another example in the textbook which leads on from the previous example which looked at the college majors. So they've said, what's the probability of a student taking one of the top 3 most popular fields? So the probability of a student majoring in one of the 3 most popular majors. Okay, so let's go back to our probability distribution for that particular example. Okay, the most popular majors, the ones that were taken the most, were biological sciences, business and engineering. These were the ones that were the most common, the most popular. Okay, so to find the probability of taking one of the 3 most popular majors, we're just going to take the probabilities of biological sciences, so 0.149, 0.134, and 0.131, and add them together. And when you add those together, you should get 0.414. The last example that I want to go through leads on from an example that we did back in our previous video in 6.1, where we looked at rolling a pair of dice. We saw in our previous video, if you go back and watch that there were 36 different outcomes that we could have from rolling a pair of dice. There were 6 different outcomes from the first dice, and there was 6 outcomes from the second. So we found that there were 36 different pairs that we could get from rolling the pair of dice. So our sample space, if you go back, looked something like this. And it went all the way up to 6 and 6. Okay. The probability of each one of these outcomes occurring is going to be the same. Each one's equally likely to happen. So the probability of each of these outcomes, I'll just write probability of each outcome, because each one is equally likely, it's 1 divided by the number of outcomes, which is 1 over 36. So the probability of throwing a 1 on the first die and a 2 on the second die is going to be 1 out of 36, so 1 over 36. The probability of throwing 2 1s is going to be 1 over 36. Okay. Let's look at the probability that both dice show the same number. Okay. So that's the probability that we get a 1 and a 1, a 2 and a 2, a 3 and a 3, etc., up to a 6 and a 6. Okay. The probability of throwing a 1 and a 1 is 1 over 36. Probability of throwing a 2 and a 2, again, is 1 over 36. 3 and a 3 is 1 over 36. 4 and a 4, 5 and a 5, and 6 and a 6, as each one has an equal probability. Okay. So add those together, you get 3 over 36, which is just 1 over 6. Okay, so that brings us back to the example that we did in our last chapter. We're going to carry on with 6.2 in the next video, and we're also going to, in that video, combine and bring together the idea of probability and odds. So we're going to see how we can transform between the two in our next video.